Welcome back to PV Online. Today we're going to look at free fall calculations. And free fall is a very specific acceleration, and that's what happens anytime you drop something that's near the surface of the earth. So what we've got over here is, imagine that we're on top of this big cliff and we're going to drop a bowling ball, let's say. And we want to see what happens to the acceleration, the velocity, and the distance that they travel over each successive second. What I mean by that, let's say that this point right here is at t equals 0 seconds. So at the starting point, this would be t equals 1 second. This would be t equals 2 seconds. And finally, we would have t equals 3 seconds. What causes us to fall is gravity, our attraction to the earth. And the acceleration due to gravity is so important we give it its own letter, and that letter is g. G changes depending on where you are. The acceleration due to gravity on Earth is different than what it would be on the Moon or on Pluto or Saturn. On Earth, the acceleration due to gravity is negative 10 meters per second squared. It's negative because it goes down, it's directed down. The actual value is negative 9.8, but for our purposes, we're just going to round it right now to negative 10. Now, the thing that's interesting about this is the acceleration due to gravity is going to be negative 10, whether we're at 1 second, or 2 seconds, or 3 seconds, or 4 seconds. This is constant. Our acceleration is always going to be negative 10 meters per second squared. But let's take a look at what happens to our velocity. Remember that all acceleration is it tells you how much your velocity changes each second. So for a time of 1 second, let's do a time of 1 second. What's going to be our velocity? Well, g is always going to be negative 10 while we're on Earth, times our time, which is 1 second. I'm just using our equation up here, the velocity equals the acceleration times time. That means at 1 second, my velocity is going to be negative 10 meters per second. Remember, all the negative sign tells you is direction. Let's continue and do it for 2 seconds. So now at 2 seconds, I'm going to use the same equation that the velocity equals the acceleration. Remember, g's not changing, so it's still negative 10, and the time is 2 seconds. That means my velocity is going to be negative 20 meters per second. Oops, negative 20 meters per second. What do you think is going to be the velocity at 3 seconds? Well, if I take negative 10 times 3, my velocity is going to be negative 30 meters per second. What will be our velocity at 5 seconds? Negative 50. And that's because each second, our velocity is increasing by 10. But now let's take a look at what happens to the distance. I'm going to use our distance equation. The only way it's different is that instead of having an a here, we substitute in g because we know the value of g. So at t equals 1 second, I'm going to say 1/2. I substitute in negative 10 there, times 1 squared. Well, what's 1 squared times negative 10? Negative 10 times 1/2, that's going to give me negative 5 meters. Now remember, the negative sign simply tells me that I'm falling down. I'm going in a direction that's down. Let's do this for 2 seconds. So I say the distance equals 1/2 times negative 10 times 2 squared. Well, 2 times 2 is 4. 4 times negative 10 is negative 40. And 1/2 of negative 40 is going to be negative 20 meters. And let's do it one more time for 3 seconds. And I've got my negative 10 times 3 squared. And when I solve that, I'm going to get negative 45 meters. Now look at what happens to the distance. In the first second, it falls 5 meters. In the next second, it falls 15 meters. In the next second, it falls 25 meters. My distance keeps getting bigger and bigger each successive second, which is what we would expect when you're accelerating. All right, let's do a couple example problems. So for this first problem, it says we have a water balloon. So I've got a water balloon that I'm going to drop from the top of a building. So I have my top of the building. And I know that the time is 4.2 seconds. We're given that. And it's going to initially start from rest, so my initial velocity is 0. So the first question is, how fast is the balloon going to be moving? We have two equations. We have the equation for the velocity, which is velocity equals g times t, and we have the equation for distance, which is 1/2 gt squared. Well, I know that the time is 4.2 seconds, and I'm looking for how fast the ball is moving, or balloon is moving, so I'm looking for velocity. So now you decide which one of these two are you going to use to solve for velocity. And we would use this one. So I'm going to use the velocity equals g times t. So I'm going to take -10 times 4.2. That means my velocity is going to be -42 meters per second. And the negative sign simply tells you that the balloon is falling down. Now for part B, I want to know how tall is the building. Well, so I want to know the distance it traveled in that 4.2 seconds because that distance will give me the height of the building. Do we have an equation that deals with distance? And we do. So we're going to use that same equation for distance, 1/2. But instead of putting in a, we're putting in g because we know the value of g, times time squared. The distance is what I'm looking for. So I have 1/2 times -10 times my t, which was 4.2, and I need to square this. And I get -88.2 meters. But what if instead I asked you to solve for time? So let's do one of those real quick. This time we have a sky jumpers falling out of a plane, and I want to know how long does it take. So I want to know how long, I'm looking for t, for it to fall 120 meters. That will be a distance. So my distance is 120 meters. You have two equations for free fall. We have the velocity equals g times t, and we have the distance equals 1/2 gt squared. You need to choose wisely. I don't have velocity, I don't have time. You have two things you don't know, so this isn't going to give me my answer. But what about this second one? We've got d, we know g, t is unknown. I can solve this. Now it's falling 120 meters, which means this distance really is a -120. So we have -120 times 1/2 times -10 times t squared, which is really going to give me -120 equals -5 t squared. All right, so now I want to solve for t, so I'm going to divide both sides by -5. And when I do that, look at what happens to the negative signs. They cancel out. So if I take 125 divided by 5, if I take 120 divided by 5, that leaves me with 24 equals t squared. Well, to solve for t, I have to take the square root of both sides. And when I do that, using my calculator, I get 4.9 seconds. Okay, we've done all the calculations for free fall. We'll see you next time.